we are looking at forces in two directions. And a specific question is from 2023, question 3. So we'll underline a few bits and pieces. Always circle or underline what you think are the important aspects, just to try and make sense of what's happening here. So we have a triangle and we have, these are both tensions and two strings. We have R, which is a ring. We have a magnitude of X acting on the ring, perpendicular to A. Okay, so T for tension on both those strings. What else do we have? So we have an angle of 60. So you know your alternate angles. That's going to be 60 as well. And on the other side is 30 and so on. Just remember, like, cosine 60 is the same as sine 30, complementary. So cosine is the complementary angle of sine. So again, you could use sine 30 instead of cosine 60. So we're going to do a vertical, and then we're going to do a horizontal resultant. And just a reminder again, I'll write it on screen just for cosine and sine disparities. You might have a different way of doing it because of that. It's just a reminder to switch it if you need be. So again, as I said, cosine 60 would be the same as sine 30. Okay, let's do our vertical component. So T cosine 60 plus X. We've X cosine 30. Stop and check if you need to. Is equal to 0.2 g, or minus 0.2 g, which of course is 2. If you said minus 0.2 g, it equals 0. Okay, simplify that. So cosine 60 and cosine 30, you should know them or remind yourself of them. You did them in the pure mathematics from last term as well. Equals 2. And from there, I think we just leave it at that. This is our first equation. Horizontal, so we've got t again. So I've got t in its own, so I've got an extra t. So t plus t sine 60. Let me just check that. Yeah. Is equal to or minus x sine 30. So unlike the last one, I'll just make this one minus sine 30 is equal to 0. You can do it either way. We're building an equation here, of course. When you cancel it on one side, it'll change its sign on the other side of the equal sign. So t plus, again, sine 60 is root 3 over 2 minus a half x equals 0. We can factor in something there if we'd like. I think with the two t's, I can do a little factoring here. It might help as you go along. So I've circled that there, or ovaled it, we might say. T bracket 1 plus the root 3 over 2. Okay. From there we have two equations. We're going to sub one in. I'll write that down, I suppose. We're going to sub one in. I'm going to simplify a few things as well, just like I did with the green there for t. So I'm going to simplify something for x now in a second. So there's our two equations. Will I sub in first, second? Just checking it. So I've got half x and root 3 over 2x. I'm going to simplify. So root 3 over 2x is equal to root 3 x, or root 3 times a half x, and that'll give us our half x. So I can plug it in there into the second equation. So I've just highlighted that there, if that makes sense. Have a quick look at it. Of course, pause the video when you're not sure a little bit. But I'm highlighting everything as much as possible here. Our first equation is half t plus root 3 over 2x. Again, I've transformed that there a little bit. So t so I've replaced there. You can see the minus half x would have been equal to 2 t bracket 1 plus root 3 over 2. The yellow and green aspects on the left hand side there have been replaced. And from there you can start to minimize, so we can bring two of those, those t's can go together when you multiply it out. So it'll be root 3t and so on. Let's just simplify it first. Root 3 times t plus, again, root 3 times root 3 is 3 over 2t, and it's equal to 2. Yeah, that first and third term will of course equal 2. Half plus 1.5. So we end up with 2 plus root 3, and of course you can put that, again, factor with the t. I'll do that in the next part here, just to simplify it down. T on the outside, and 2 plus root 3 is equal to 2, so t is equal to 2 all over 2 plus root 3. Calculator out for that bit as well to find our force. So the tension, which was T, 0.536 to 3 significant figures, and of course newtons is the unit for tension and force. Second, lastly, find the value of x. I'm going to again sub something back in. What's the easiest route? I think the second one might be, but I'm going to write it down anyway. The first one, our first equation, is half t plus root 3 over 2x is equal to 2. It's okay. I think the second one might be easier. Yeah. You want to pick the shortest route. You don't want to think about it for too long either. Perhaps. I think half x, plug in our t, and then double it up might be better. Half x then will equal 2 over 2 plus root 3, and that actually can be cancelled. Okay, let's do that. The second one is t plus root 3 over 2, t is equal to half x so bring our half x over to the left. Half x is equal to t, which we're going to replace. We have t now. 2 over 2 plus root 3. And we put a bracket around it as well. Make it look contained. And then, of course, our t times root 3 over 2. Which is 1 plus root 2 over 3. We can also simplify that again. See that in a second. So x is equal to 2 times all of that. Divided by half, or well, times 2 on both sides. And actually, if I get the same denominator here, 2 times 1 over 1 would be 2. So 2 plus root 3 over 2 is the exact inverse of what we have in our first bracket. Which is nice and tidy, isn't it? Nice and neat. So of course 2 times 1 is our answer for x. X equals 2.